Hi everyone, this is Professor Oaks, and this video is about factoring quadratics with integer coefficients, and we are going to actually do all of the problems in this section using the method that you may have already heard about, and that is called the AC method, or usually some people call it the factoring by grouping method, because you will need to use factoring by grouping here. So the AC method. All right. So what this means is that what we need to do is actually break this middle term here up into two terms with coefficients that multiply to get A times C and add together to get whatever B is. So remember, these are quadratics of the form ax squared plus bx plus c. So in this particular case, it's 1x squared. So a is 1 plus 7x, b is 7, and c is negative 44. So a times c is 1 times negative 44 is negative 44, and b is 7. All right, so we need to figure out what numbers multiply together to get negative 44, but add together to get 7. So 1 times negative 44 was negative 44, but 1 plus a negative 44 was negative 43. So that is not correct. All right. So we have 2 times negative 22. That's negative 44. But 2 minus 22 is negative 20. So that is not it either. And then let's say we did 4 times negative 11. That's negative 44. But 4 minus 11 would be negative 7. So I know that I'm close now because that's negative 7, but I should have 7. So what if I make this a negative 4 and a positive 11? Well, that's negative 4 times 11 is negative 44, but negative 4 plus 11 is 7. So I know that this is my correct pair of numbers now. So what I do then is I take the x squared plus 7x minus 44, and I use the negative 4 and the 11 to rewrite 7x as negative 4x plus 11x. So I have x squared minus 4x plus 11x minus 44. Then I factor the greatest common factor out of the first two terms, which is an x, and a greatest common factor out of the second two terms, which is an 11. So I have x times x minus 4 plus 11 times x minus 4. Now I see that the GCF is x minus 4. So I have x minus 4 times, and then once I factor that out, I see that I have x plus 11 left. All right, so that means one of the factors here is x minus 4. All right, here it is right here. So now let's try another great example right now. All right, so we have x squared plus 11x plus 18. So we have a is 1, b is 11, c is 18. So a times c is 1 times 18 is 18, but b was 11. So what I have here is I have, well, I know that 1 times 18 is 18, but 1 times 18 is 18, but 1 plus 18 is 19, so that's not right. Then we have 2 times 9 is actually 18, but 2 plus 9 is 11, so that actually is correct because I wanted 18 and I wanted 11. All right, so now I can rewrite x squared plus 11x plus 18 as x squared plus 2x plus 9x plus 18. Remember that I'm using the 9 and the 2 that I just found, all right, to factor this. So now I factor the GCF, the greatest common factor out of the first two terms, x. So I have x times x plus 2, and the greatest common factor out of the second two terms, that would be 9, so plus 9 times x plus 2. Now my greatest common factor is x plus 2, so I'm left with x plus 2 times x plus 9. So that means that x plus 9 is one of the factors. All right, so again, here was the x plus 9 that is left after I factor out the x plus 2. So I hope that you enjoyed that example here. So let's try another one. So for this problem here, we have x squared plus 2x plus 2. So a is 1, b is 2, c is 2. So a times c is 1 times 2, 2, and b is 2. So 1 times 2 is 2, but 1 plus 2 is 3. And then the only other possibilities to get 2 would be a -1 times -2, which is 2. But -1 plus -2 is -3. So we see that this expression cannot be factored. All right, so there you go. So that one was as simple as just going through two possibilities here and saying that it could not be factored. So now let's try another example here. So this one is factor, let's see, what is it? 15x squared plus 16x plus 4. All right, so now what we're going to do is we're going to look at the a, which is 15, the b is 16, the c is 4. So a times c is 15 times 4, which is 60, and b is 16, and we'll work our way through the possibilities just like before. So what do we have here? Well, we have 1 times 60 is 60, but 1 plus 60 is 61, so that's no good. 2 times 30 is 60, but 2 plus 30 is 32. All right, 3 times 20 is 60, but 3 plus 20 is 23. All right, so we have 4 times 15 was 60, but 4 plus 15 was 19. Then we have 5 times, so what would this, oh, you know what, I actually know which one, I actually think that I know which one it should be. If you have any issue with this, it should be, but before we get to that, 5 times 12 is 60, but 5 plus 12 is 17. And then, of course, 6 times 10 is 60, and 6 plus 10 would be 16. So if you notice what's going on here, just so that you're a little bit aware of the situation, I could see that these numbers were actually going down as I was adding them together, right? Because these numbers were getting closer and closer together. So just keep that in mind as something else to think about as well. So I knew that I want to try to get to 16. So if the sum was 61, I needed to get two numbers that are a little bit closer together than 1 and 60. So anyway, I see that 6 and 10 are my numbers here. So I have 15x squared plus 16x plus 4, and I expand the 16x into 6x plus 10x. Then I factor out the GCF out of the first two terms, and that would be where is it? Is that a 10? Yeah, that is a 10. So that should be 3x. So I have 3x times 5x plus 2. Then a GCF for the second two terms, that would be 2. So plus 2 times 5x plus 2. and then I factor out the GCF of 5x plus 2, and I'm left with 5x plus 2 times the 3x plus 2. So I see that one of the factors is indeed 3x plus 2. All right. So hopefully you're enjoying this. So let's do another wonderful example here. So we have 6r squared plus 13r plus 6. So A is 6, B is 13, C is 6. So A times C is 6 times 6. That will be 36, and B is 13. So I have 1 times 36 is 36, so 1 plus 36 is 37. 2 times 18 is 36. 2 plus 18 is 20. 3 times 12 is 36, but 3 plus 12 is 15. 4 times 9 is 36, and 4 plus 9 is 13. So I know that 4 and 9 are the two numbers I was looking for here. So I'm going to write the 6r squared plus 13r plus 6 as, let's see, I'm going to use the 4 and the 9, so 6r squared plus 4r plus 9r plus 6. Then I find the GCF from the first two terms, and that would be, well, what is that going to be? That will be 2r. So I have 2r times 3r plus 2. And the GCF from the second two terms is 3. So plus 3 times 3r plus 2. So if I factor out the GCF of 3r plus 2, I have 3r plus 2 times 2r plus 3. So I really hope that you enjoyed this example. So you can see that the factor that is listed here is 2r plus 3. All right, so let's do just, well, you know what, let's do this example, but I'll do this over on another page here. So it was 12p squared plus p minus 1. So A is 1, B is 1, C is negative 1. So A times C is, oops, A is 12. Yeah, 12 times negative 1 is negative 12. And then the B was 1. So what do we have here? Well, numbers that multiply to give us negative 12. So negative 1 times 12 is negative 12. So negative 1 plus 12 is 11. All right, negative 2 times 6 is negative 12, but negative 2 plus 6 is 4. And then we have negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. So there we go. I see that those are the numbers that I need here. Negative 12, 1. So I'm going to have 12p squared plus p minus 1 is now going to be 12p squared minus 3p plus 4p minus 1. I'll find the GCF from the first two terms, so that's negative 3p. So we have negative 3p times 4p minus 1. And then the GCF from the second two terms, well, that's just 1. So plus 1 times 4p minus 1. Then I see I have a GCF of 4p minus 1. So what do? I have 4p minus 1. I factor that out, and then negative 3p, right? Negative 3, is that 3p? Oh, no, sorry. That should be 3p, not negative 3p. I don't know why I have an extra negative sign there. So 3p plus 1. All right, so there is 3p plus 1. So there we go. We see that one of the factors was 3p plus 1. There we go. Alright, so let's try another example, and this will be our last one, but this will hopefully seem repetitive at this point, meaning that you should be used to the pattern of using A times C, or get used to it at some point in your life, because remember, you should just remember everything. Don't forget a thing. Alright, so factor the expression below completely. So we have 5x squared plus 2x plus 12. So A is 5, B is 2, C is 12. So A times C is 5 times 12, 60, and B is 2. And so, well, we want numbers again that are going to be close together. So, but we can try them. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 6 times 10. All right, and then I think that is it. And we've had 60 before, so just keep that in mind, that this is not one of those that you should be too worried about, because it's not too particularly large of a number. But in either case, we know that 1 plus 60 would be 61, 2 plus 30 would be 32, 3 times 20 would be 23, 4 plus 15 would be 19, 6 plus 10 would be 16. I did not do 5 times 12 yet, but I see that wouldn't actually work in this case either. I didn't even try any of the negative ones, like -1 times -60, -2 times -30, -3 times -20, -4 times -15, -6 times -10, or -5 times -12. But you see, I wouldn't have needed to anyway, because I want it positive 2, and none of these would be a positive number. All right, so keep that in mind also. So now I see that none of these are going to end up being 2, so this one cannot be factored. What a time to be alive. I really hope that you enjoyed this video on factoring quadratics with integer coefficients, and hopefully you're already looking forward to the next video. Thank you and have a great day.